Welcome to today's webinar. The topic today is definition and analysis of construction stages in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the Dlubal website, the German and English webinars, newsletters, and so on. I will be the moderator today, and I will answer questions together with Thomas, and Adrian will be the presenter, but my two colleagues can introduce themselves.
Yeah, hello, my name is Adrian. I'm responsible here at the Dlubal Software company for the customer support and also for the development. For the customer support, mainly for concrete design and related topics, and for the development for different topics, and but especially also for the construction stages, and that's the reason why I'm today the presenter, and I show you today the construction stages in RFEM 6.
Hello, my name is Thomas Günther. I'm a part of the customer support team at Dlubal, and I will try to answer your questions today in the webinar. And my main focus is on web service and API.
Okay, thank you. Then we can switch off our webcams so that the attendees can see the full screen. For the attendees who participate the first time in a Dlubal webinar, you can show or hide the control panel with the arrow here, and then enter your question here. And we will answer you. If you don't get an answer during the webinar because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email questions to info@dlubal.com. To the agenda today, at first, Adrian will define the construction stages with the help of web services and API. He and Thomas wrote a script and he will use that. Then the next point is the determination of internal forces and moments. Then follows the design and the result evaluation and documentation. Okay, that's all from my side. I hand over the screen to Adrian.
So you should see now my screen.
Yes.
And our example. Yeah. Okay, then I will start. Yeah, today is our third webinar regarding the construction stages. Today, I would like to show the construction stages analysis based on an example which I got from my colleagues from the Timber team. They use it in their Eurocode 5 training. This example is based on a customer example from our customer Fast and App. You could also find it on our website. Partially, it was designed in RFEM 5. It is an 18-story mass timber hybrid building, which was built in Vancouver. The first story of the structure is made of concrete. Also, the core is made of reinforced concrete. The columns are made of timber. They have a square cross section with 35 centimeters aside. The slabs here, the slabs are made of 5-ply cross-laminated timber floor panels, CLT panels, with a which got a depth of 24 centimeter. But the focus today is not the timber design. It is rather the determination of the internal forces for the design and the consideration of the construction stages. in the beginning, I have the whole structure, which was calculated without considering the construction stages. And first I will have a look at the results without consideration of construction stages. So to do this, I switch over to the wireframe model. We have here the internal forces in the slabs, but to have a better overview, I will create a result section through the building. You can find it here. I will do it graphically with 2 points. And I will place, to have an overview, I could choose different planes, but I choose a plane which crosses the building core. So, for example, from here, from this upper edge to this lower edge, the second plane here of the columns, and then say OK. It will probably need a bit to load the results, and then I switch off the surface results to have a better overview, and I look here from the in Y direction at the results. I look at the results for combination 1. Load combination 1 includes the only permanent loads, factorized permanent loads, but no live loads or wind loads. The effect of considering or not considering construction stages is especially related to the permanent loads, and that's the reason why I choose here the combination 1 to look at the results. So here it is recognizable that the moment, for example, here in this area, that the moment over the support is decreasing over the high of the building. So as higher the story gets, as lower the moment above the support is. This effect appears because the deformation of the columns are added up in this structure, on this situation. We can have a look at the actual deformation of the columns, and you see it's not the values themselves, doesn't matter, but you see that if I look at the deformation, it's getting it increases with the high of the building or with increasing stories. And that's the reason why I get here a smaller moment about the support. So, and yeah, it is also caused by the slender columns themselves, because they are have a quite low stiffness. But in reality, the permanent load is not applied at once at the complete building. The structure is built step by step, and also the permanent loads are applied step by step. For example, typical story by story. It depends on how you build the structure. but during the building process, some of the deformations are compensated. And at the moment, with this structure, we do not consider this fact. So this is not considered because we do not consider the building process. And this leads to this effect here. To consider the building process, you could use the add-on construction stages, which you could activate here in the base data. There where you could also activate all other add-ons. You find it here, construction stages analysis or CSA. I will activate the add-on. And with activating the add-on, I get here the possibility for an input. So I can, for example, here create a new construction stage. There are two components for the input of construction stages. The structure side, where you define which parts of the structure are active, and the load side, where you decide which loads are applied in the single stages. We will start here with the structure side. So with this dialog, after I've created stages here, I will also get in the load cases and combinations objects for the construction stages. But first I have to create here construction stages. The common way to define these construction stages is to define it here in the dialog. I will show it short. You can here create the construction stages depending on how much you would like to consider, and then you could activate here the elements you would like to consider. So, for example, members and surfaces, and then depending on the options here, you get additional registers here for the members, for the surfaces, and in this and here you can choose the objects graphically. For example, here the columns of the first story, and the same for the surfaces. You could also do the input by hand numerically. So this is the let's say common way. This way was shown in the two older webinars in detail, which you find on our website. But today I want to show a different alternative way of the input. The construction stages could be also connected to our programmable interfaces, to our web service and API, and this is what I would like to use today, or what I would like to show today. So I completely delete the stages again, so that the input is empty. I leave the dialog. Using our programmable interface for the input could be an option if you have, for example, structure which got a high number of stages and which are all similar. So like here, but you could also use it if you have similar projects where you always want to use the stages. This could be also an option for such situation. I will maybe switch off the results. My colleague Thomas created a small program which we could use for the automatic input of the stages. And the program works as following. First, I have to choose or select a row of nodes in a way that for each story there should be a node. Maybe I can show it here. A node in the beginning of the story and at the end of the story. If I then start the program which we generated with our API, or which use our API, the program based on the selected nodes generates groups of elements depending on their set coordinates. So one group is generated for each story, and depending on the coordinates of the nodes and lines and members and surfaces, they are assigned to a group. So for each stage, there's one group, or let's say for each story, there's one group. And afterwards, the program then generates the stages automatically, and for each story, one stage, and it assigns the elements automatically to the stages. So we wrote the program in a way that it uses members and surfaces, but that's just for an example. So I will start now the Excel here, and we will see what the program is doing. In the beginning, it gets all nodes, and then all other objects. So it first gets all nodes, then the selected nodes, and then all other objects, and it will group them to let's say to the single stories, and then it will write the input for the construction stage. The writing or setting the input should be quite fast. Reading needs a bit time. Yeah, so now it's done. And we see here the input. I will not explain the programming in detail, or the source code in detail here, but we will attach the source code afterwards to the recorded webinar, and if you like, you can have a closer look, and also if you like to know more about our web surface and API interface, or if you want to have more examples or introduction videos, for example, you find detailed information here on our website here in web service and API. There should be some introduction videos and so on. So here, but for our example here, the program, or our program we made, did the input for the stages. So I can here go through and check the generated stages and the assigned objects graphically. There are a lot of columns, members, and surfaces here. It looks reasonable, but now I only have to assign for the first stage the supports. Of course, this could be also done with a program, or could be also part of a program. But in this example, we did it, yeah, just for the members and surfaces, and it should be not a high effort to select the supports, nodal supports and line supports afterwards, because I only have supports in the first construction stages, or in the first construction stage, and I could here assign them in the dialog by clicking here all nodal supports, and all line supports should be used in the first stage. So that this is not the big effort. So that's the reason why we put it not in the program. Also, I have to assign line hinges for the construction stages. The line hinges were maybe not shown in the whole structure, but we have several line hinges in the structure, and they are assigned between the CLT slabs, and I now will use them also for the construction stages. So I will select all construction stages and activate the register line hinges. And if I go here to the register and use this all button, the program automatically chooses all line hinges which are part of surfaces which are active in this particular stage. So if I click here, for example, on the first construction stage, I see here which line hinges are active, and it's written in a way that first there's the number of the surface, and then all lines which have line hinges. So for example, here for surface number 100, there are the following lines with line hinges, and the same then, well, it's the same way then for surface number 102 and so on. So the program uses the line hinges for all surfaces which are active in a stage, and automatically assign them or activate them. Yeah. So yeah, this is done here. Okay. So this should be the input for the structure. So the input should now be complete. I can of course check it here graphically again, but then now I could continue with the input on the load side. Once there were stages here generated, or generated. You have an input here in the load cases and combinations for the construction stages, where you could open the dialog for the loads, or you could also use this button here at the top, and it opens the stage which is selected here. So for example, this. So here, and here you have the input for the construction stages, for the load cases and settings regarding the calculation and the combinatorics. I will start here, not in the main register. I will start in the with the load cases, with assigning the load cases, and First, I will choose the first construction stage, and there I would like to assign the self rate. So if I assign the self rate in the first stage, the program automatically recognizes that this is a permanent load case. Permanent means that once you have activated such a load case as permanent, it is considered in all following construction stages. And here there's a, let's say, special kind of load case, because this load case includes the automatically determined self rate. The program is able to recognize that if in a construction stage, that if when there are new elements applied, that there's automatically also applied the self rate of these elements, which are which is also determined automatically. And also, if you have here additional loads applied to the surfaces, for example, or to the members, the program is able to check when an element is activated for the first time in the construction stage. It applies also all related loads of this elements or of this element, which are included to the permanent load case here in this example to the self rate. And then we can check it. For example, if I click on a other construction stage, you see here that there is active the self rate, and this is the case in each construction stage. In the last stage, when the building process is completed, I will apply the live load. The live load is used as non-permanent by default, because it is not, if I, for example, use it in an earlier stage, it is not considered in all following stages. You could also check it or decide if a load is considered as permanent or not by clicking this check in the construction stage where it was first activated. In this example, I would like to use the construction stages mainly to consider a correct distribution of the permanent loads. Of course, it would be also possible to design intermediate stages and assign temporary loads not only to the last stage, but in this example, my focus is mainly to the permanent load, to the self rate, and to its correct distribution regarding the building process. So when I've done here the input, I can switch back to the main register. Here you find different settings. For example, settings regarding the construction stages analyzes, if it is done or if it should be done with load combinations or with load cases and result combinations and linear superposition. At the moment, the current state of development, we only offer this option with the load combination. The other option will follow later. The possibility to consider these stages by using load combinations is the more complex method compared to the linear method. So here you could also handle non-linear structures. Compared to the linear superposition, it's a bit more complex, but yeah, you could use it for all kind of structures. Yeah, here you could choose the statistical analysis settings. So stages at the moment have to be calculated always with the Newton-Raphson solver, but you could choose geometric linear or p-delta or different possibilities. Here I calculate geometrically linear. Yeah, the another option is here. The option 2, it's maybe a little bit hidden, but this is the option regarding the combinatorics. So if you would like to consider the automatic combinatorics, you could use this option or this combination wizard. And here in my example, or in our example, I would like to do the combinatorics for the last stage when the building is completed. And this is also the stage where I would like to design then later the structure. You have also here some detailed settings. I would use the combinatorics only for the construction stages. And there's one important thing here about the settings. You have to make sure that the statistical analysis settings here and for the stages is the same. Otherwise, it will not work. I guess you should get a hint or something, but it will not work if you use different methods for calculating the load combinations than for calculation of the construction stages. Okay, so I will agree it here. And if my input is correct, then I should see here the action combinations, which are generated. And I see here that they are generated all for construction stage number 18, which is my final, my last state. If you, for example, do the combinatorics also for other construction stages, you get here this, let's say the same action combination several times, but for different construction stages. And it's quite similar to the load combinations. The load combinations should be also generated automatically. Here there are the let's say common or typical load combinations for the design, which are all done for construction stage 18. You see it here also in the description. But here you see next to the let's say common normal combinations which you use for the design, you have also other additional combinations. These are let's say auxiliary combinations which are generated to consider the factorized permanent load. These auxiliary combinations are generated in the case if you have a factorized permanent load for these stages. So here in the example, it's 1.05. Normally, the stages themselves are calculated with 1.0 factorized permanent loads. That's the default value. You could also change it. But then if you, for example, use a stages calculation with 1.05, then you need the auxiliary combinations to consider or to have the results for 1.0 permanent load for the characteristic combinations. So so as soon as you have different factors for the permanent loads in a design, these combinations are generated, and it's like 2 times stages calculation, 1 time the stages calculation with 1.0 and one time another time the calculation with 1.35 factorized self-rate. This is done because you have the possibility to consider the nonlinear effects correctly. If you look at such auxiliary combination in detail, you see a bit how the systematic for the construction stages is working. So we have, for example, here the combination for construction stage 1. There is no construction stage before 1, so there is no initial state which has to be considered, no existing stress distribution which has to be considered. There's only the, let's say, structure side which has to be considered. So this the information about which part of the structure is active in this combination. And if I go to the combination or to the auxiliary combination for construction stage 2, I see that here it uses an initial state which is considered for construction stage 2. So the initial state is the result from the factorized result, or the calculation with factorized load from construction stage 1. So there's an initial stress situation which is considered, and it considers the structure side from which is defined in construction stage 2, and it works in this way. And if you would like to define the combinations manually, you could do it in such a way. You could generate a new load combination, which is then a user-defined combination, or you switch off the combination wizard, and then you could use only manual combination or combinatorics. The definition of manual combination was shown also in an earlier webinar. It was the first construction stage webinar. There I've generated also manual load combinations, but this should not be part here. So my input here for the load combinations is ready, and for the loads, I agree. Yes, the results have to be deleted, and before a calculation could be started, I will check the input for the timber or for the multi-layer design. I have here activated the timber design. The add-on is active. I have a design situation here, and there's an existing input for the design. So I will have a look on the design situation where I have the information about where this design situation is used. So this is used in the timber design with doing the input for the construction stages. My load combinations has changed. These load combinations, which are generated here, are still related to the design situation 1. That's the same situation like it was in the beginning. So for considering the construction stages in the design, I have to do no more. There's no special thing I have to do. As soon as I have the input here for the construction stages and the load combinations are generated for construction stages, these construction stages are also considered for the timber design. So, okay. If I would like to calculate now the structure, the calculate will, due to the size of the structure and because there are a few construction stages, it will need a bit time to calculate such structure. We have to calculate here the origin construction stages, which are using the 1.0 factorized permanent load, and we also have to calculate the load combinations which consider the factorized permanent loads, and of course also the common combinations or the normal combinations have to be calculated. For stages calculation, we could not use multi-threading technology. So this means the calculation for these stages have to be done step by step after another, because one stage needs the result from the previous stage. So the calculation is not able to calculate the construction stages parallelly. If you have combinations or load combinations here in one stage, the calculation should run with multi-threading or should run parallelly. The stages calculation here in the structure needs for one stage about 5 to, let's say, 10 seconds. And also the combinations needs a bit of time. So the whole calculation will be definitely be longer than 1 minute. So I will not show it in the webinar. On my computer, it took, including the timber design, something about, I would say, 8 minutes. I have a quite common computer, which is not the newest. But it is not the smallest structure. It would need a bit of calculation time. So to avoid this calculation time, I have saved the completed structure with results and have it here. And I have I will start with the results for the internal forces, for the bending moments. Same situation as I showed it before for the structure without considering construction stages. I also take here a look at combination 1, which includes only the permanent load, and I will have a look again at the results here in this area and at the moments above the the columns or above the supports here, and I get a behavior that now the moments are also decreasing. Yeah, let's say till the middle of the structure, but then they are increasing again. I could also compare it. I prepared it in the presentation, both situations next to each other. On the left side, the internal forces for combination 1 without construction stages, and on the right side, the results including construction stages. You see here in the beginning, there's not that big difference, but then with increasing stories, the moment above the support is decreasing in both cases, but not as much in the case with the construction stages, and in the case with the construction stages only till the middle of the building, and then it's increasing again, while without the construction stages it's only decreasing till the top story. And the results, if you compare the results in the top story, they are quite different. Yeah. The same behavior, or it's vice versa behavior for the moment in the field. When the moment above the support is decreasing, the moment in the field is increasing. So the maximum moment in the field for the situation with the construction stages should be somewhere in the middle of the structure. So I can try to explain the effect for the construction stages, or explain the behavior. So the question is maybe why is there a maximum for the moment about the support in the first story and in the top story, and in the middle there's the maximum for the moment in the field, but the minimum for the moment above the support. In the top story, you have, if you take, I don't need the exact values, but if you have a look at the normal forces, in the top story you have the smallest normal force. The normal force is increasing in the columns till the first story. Here in the top story you have the smallest normal force, but if you take a look at the, let's say, at the support or at the columns below this point, you have the lowest stiffness here at this point. In the first story, so at the bottom, you have the maximum normal force in the columns, but you have the highest stiffness, because there are no slender columns, or there's only one column below this point. And in the middle of the structure, you have, let's say, medium-high normal force, but also medium stiffness. And this leads to the effect that here you get the maximum actual deformation of the column. So if I switch to the deformation of the columns, the maximum is here somewhere in the middle. And that's the reason why you get here the smallest moment above the support, and the maximum one moment, I switched it off. That was the wrong. That's the reason why you get in the middle the minimum value for the moment above the support, and the maximum here, maximum moment in the field. This is a, let's say, typical behavior for such structures, that you always have to look at the middle of the building, where you choosing which parts you would like to design, or which is the leading situation. So for the moment in the field, this would be the slab which gets in the middle, which gets the most bending moment, or the highest bending moment. Yeah, and the biggest difference that between these situations was, of course, the results in the top story. So here I have a quite big difference. So this should be the part about the results compared with and without considering construction stages. At the end, I will show for a short moment also the printout report. So that's all from the result side. If you would like to document the results, the possibilities are, let's say, quite the same for a structure where you consider the construction stages. I have here prepared printout. So you have the graphics or result graphics as common as in a normal or in a structure without considering construction stages, but you should have one additional point. I will open the printout. If you use, for example, the multi-print, okay, it has to be generated. So I prepared a printout report where you have pictures or graphics for each construction stage. But I guess, I'm not sure if I've opened it before. That could be the reason why the graphics have to be generated first. I don't remember. So here, for example, you could use the multi-print together with the object construction stage, and you could, for example, print for each construction stage the structure with its permanent loading. In this example, there was the self rate, which is here not shown in this picture. Here's only shown the additional dead load. Yeah, and you could print it with using multi-print, and of course you could also print the results as for a let's say common structure. So there are no more special things about it. So this should be all for today from my side. I will hand over the screen again to Andreas, or Andreas, you would show some additional information.
Yes, thank you, Adrian, for this nice presentation. Yeah, it would. You showed another possibility to create construction stages. As you already mentioned, you showed in previous webinars how to do that in the program only. I would like to show it on our website, where you can find such webinars. Before I do that, and I will also show you where you can find the recording and the models of today's webinar. Before I do that, I would like to show you some additional information. if you want to visit the BAU in Munich next week, you can visit our booth. We have a booth there, and you can book your free live demo, and then you can secure your free ticket. You can also use the QR code. You can download that file here, the presentation, from our website. I will show that also in the next steps. If you don't have time to visit the BAU in Munich, you can book your free online appointment. For example, a free product demonstration, or you can get an offer if you want to or if you want to buy our programs or add-ons. Then you can contact our sales team with that link here, or you can scan the QR code. Then I go to our website before we close the webinar. On dlubal.com, you can see news and events here. And then down here is the webinar button. And if you click on it, the page should be opened. Okay, that's today's webinar. Those are the webinars of the next weeks. And if I click on today's webinar, you will get also an email with the link to that page here, and also with your attendee certificate in the next days, maybe tomorrow or at the beginning next week. And then the recording will be here. The presentation slides will be here. The code will be here for the creating of the construction stages, and the model is already here. Okay, that should be also all from my side. I thank you for your attention. Thanks to Adrian for this nice presentation. Thanks to Thomas for his help answering your questions. Maybe last hint, when you leave the webinar, you can score the webinar. Just note that the worst score is 1 and the best score is 5. You can enter wishes for future webinars, but you can leave the field empty or enter a sign such as minus or so. Okay, then thanks again and have a nice day. Bye-bye.
Thank you. Bye.
Bye.